in our example, you can check that, for example, for the interaction of factor A at level 1 with factor B at level 1, what you're going to have is a y bar when A is at level 1, B is at level 1, and I've averaged out over C. So I average the cube front to back, average out over factor C. I grab this guy and this guy and I average them. So 52 and 60 average, I guess, to 56, and that gets put into this calculation. I've got a 56 minus the grand average, mean, plus A number 1 plus B number 1. So that's going to be 56 minus 64.25 plus minus 11.5, since the main effect of factor A at the first level is negative. I've got to be careful to carry the minus sign there, plus 2.5, and when that is all said and done, that's a reasonably small number. Okay, that turns out to be 0.75. Now, it's easy to figure out what AB12 is, AB21, and AB22, because those two have to sum to 0 over levels of factor B. That is, if I take these two-factor interactions and add out over levels of one of the factors, I have to get 0. That makes this thing have to be minus 0.75. Similarly, this guy and this guy have to sum to 0, because if I add over the first index, add over levels of factor A, I once again have to get a sum of 0, and so this guy has to be minus 0.75. Finally, if I look, for example, at these two, they have to add 0 over levels of factor B. So there's a 1 and a 2 there in the second slot, and that means that this guy has to be plus 0.75. What I've just argued or told you here is that these add to 0 over levels of any single factor, and I can use that in this way of calculating one of these guys and then just getting the rest of them by doing appropriate sign changes. So what do I make of this? I make of this that if I was to average front to back on this cube and then think about parallelism or lack of parallelism after averaging out over factor C, these are pretty small numbers in magnitude, and there's basically minimal lack of parallelism after averaging front to back on this set of y bars. I could similarly calculate AC two-factor interactions. So AC11, that's a y bar at the first level of factor A, the first level of factor C averaged out over factor B, minus a grand average y bar plus an A number 1 plus a C number 1 that is going to be a 57 minus 64.25 plus a minus 11.5 plus a minus 0.75, and that turns out to be now somewhat bigger. That turns out to be 5, and that means that AC12 has to be minus 5, since it has to add with AC11 to get 0. AC21 also has to be minus 5, and AC22 then is plus 5. If I look at the magnitude of these guys in comparison to the AB two-factor interactions or the main effects of B and C, those are pretty substantial. So what this says is that after averaging over B, there is some substantial lack of parallelism on an AC interaction plot. That is, I cannot really think of factors A and C as operating sort of separately on this response. So average top to bottom on this cube. Ask yourself then, does it look like I could think of factors A and C as separately impacting yield? And the answer is no. What that says is changing the level of factor A produces a different change in yield depending upon what level of factor C is involved. So this says that changing A produces a different change in Y depending upon what level of C is involved. Finally then, if I want to talk about not AB or AC interactions, but I want to talk about BC interactions, say BC11 is then Y bar when both B and C, or average Y bar when both B and C are at their first level, minus grand average Y bar plus B number 1 plus C number 1, and that is 66 minus 64.25 plus 2.5 plus minus 0.75, and that turns out to be exactly 0, which means then that BC12 is 0, BC21 is 0, and BC22 is 0, because these things again have to add to 0 over all levels of the any one of the two factors involved in their naming or in their definition. This picture, or this computation, says that if I averaged left to right on that cube and asked about parallelism, there would be perfect parallelism. Let me again come back and say something about this and show you a picture. As I say, the biggest interactions here are AC interactions. Changing A level produces a different change in Y depending on what level of C is involved. Let me try to illustrate that with a picture. So let me show you this figure. And this is what I get for, these are Y bars with factor B averaged out. So these are averages of Y bars over levels of B. That's bottom to top. Of the cube. And the point is, I look at this picture and there's lack of parallelism. So this lack of parallelism is indicative of fairly large AC two-factor interactions.